Welcome. We are here today to present to you a webinar on domestic legislation for ventilation. This is not a CPD, but we can arrange for one of our team to deliver this to your organisation. Please feel free to get in touch with us.
During this seminar, we will be covering short background of national ventilation, how Part F and L currently is, various ventilation systems within Part F, any design considerations, and then any questions you may have at the end.
We are based in a rural location just outside of Taunton called Boroughbridge. Originally, we worked out of Stoke House up to 1998 before moving across to Curload up to 2003, where we then moved to our current location.
Historically, building regulations across the United Kingdom were combined, but this has now changed to having each constituent country having their own versions of building regulations. England were the first to publish their latest building regulations. We expect the other countries to follow shortly after, which each having finished their consultation period and looking to publish their documents soon. Wales have also recently published their versions. We will look to amend this presentation as necessary, ready for the CPDs. Once these are published, we will look to update this presentation to include them.
The new 2021 edition of Part F, L and O take effect on the 15th of June 2022 in England. There is a 12-month grace period which ends June 2023. Following this, each individual plot must follow these regulations in order to comply. Historically, building regulations applied to each site, multiple houses. This has now changed to being specifically applicable to each plot, i.e. individual houses. This means that if a site designed to previous regulations hasn't started every plot by June 2023, any remaining plots need to be redesigned to meet the 2021 edition.
With the introduction of the 2021 edition, the main focus is health and energy efficiency, which we see as a positive move following the COVID-19 pandemic. The regulations look to minimise entry of external pollutants, ensuring humidity and pollutants are extracted effectively and efficiently, and setting minimum levels of fresh air to ensure good occupant health.
Interaction with other approved documents. Part B is all about fire safety. This applies to ductwork and penetrations through walls and fire structures. Part B also gives guidance on escape windows and openings. These may well be larger than those required for ventilation in Part F and should take precedence. If in doubt, always consult the fire officer.
Part F cannot supersede Part J, when permanently open air vents are required for combustion.
Interaction with Part K and M state that controls should be within reasonable reach of occupants.
And finally, Part O. Purge ventilation rates may exceed those found within Part L. The higher of the two standards should be followed. How other approved documents are met is up to the contractor by consideration must be given where required. A further session of ventilation for Part O will be available.
The various ventilation systems within Part F are no longer classified between 1 and 4, but are now called natural ventilation, previously known as System 1, background ventilations and intermittent extract fans. Continuous mechanical extract ventilation, previously known as System 3, continuous mechanical extract, MEV. Mechanical ventilation with heat recovery, previously known as System 4, continuous mechanical supply and extract with heat recovery, MVHR. So there are now 3 types of prescribed ventilation systems, with passive stack now removed. Other system types, such as positive input ventilation, also known as PIV, may be used to comply, but expert advice should be sought.
Building airtightness has been emphasised, with the additional requirement that all buildings must be airtightness tested. Airtightness is important as it helps to ensure that the energy that's used within the property is retained. As you can see from the thermal image, which compares a passive house to a standard house, the standard houses has more heat radiation. As per approved document F, houses are now classified as less airtight or highly airtight, depending on the air permeability, which is measured using meters cubed per square metre.
The minimum air tightness of buildings is 8 meters cubed per square metre at 50 pascals. If air tightness is greater than this, the building will not comply. If a dwelling designed with natural ventilation tests as highly airtight, expert advice should be sought, or a continuous mechanical extract ventilation system should be installed. We recommend that intermittent extract be used between 8 and 5, decentralized mechanical extract ventilation between 5 and 3, and anything below 3 should be mechanical ventilation with heat recovery. The graphic here shows the value at which a building changes from less to highly. That varies depending on whether it is as built or design air permeability.
The minimum intermittent and high extract rates between the 2013 and 2021 editions remain unchanged and are presented within Table 1.1 and 1.2. For intermittent systems, these are 60 or 30 for a kitchen, 30 for a utility, 15 for a bathroom, and 6 for a toilet. For continuous systems, these are 13 for a kitchen, 8 for a utility or bathroom, and 6 for a toilet.
Key change within Part F is the whole dwelling ventilation rates, which have been increased. When applying the whole dwelling ventilation rates are to be taken from Table 1.3 and selected depending on the number of bedrooms within the dwelling. For every additional bedroom, there is a requirement to add 6 litres per second. In addition to these changes, the minimum ventilation rate should not be less than 0.3 litres per second per square metre of internal floor area, including every floor. The higher of the two values calculated should be used. There is no specified requirement for boost speeds, as it is dependent on various factors, such as lifestyle. Consider a minimum of plus 10% boost, as this potentially gives an audible confirmation to users that the unit is in boost operation. Also to note, one habitable room, for example, a bedsit or studio, would fall under one habitable room, and would need to meet a minimum ventilation rate of 13 litres per second.
Mechanical ventilation systems in regards to approved Document L are largely unchanged, but continue to specify that systems should be designed to minimise electric fan power, which is called specific fan power, and should not be worse than shown in the table. The only change here is the heat recovery efficiency, which was originally stated to be a minimum of 70% within the BSCG in line with 2013 edition, and has increased to a minimum of 73% as part of the 2021 edition. This continues to be a requirement to have a summer bypass and variable speed controller for supply and extract ventilation systems. Within SAP, the notional buildings will use natural ventilation with intermittent extract fans.
Here is an animation of natural ventilation, as you can see per the animation. There are background ventilators which allow air to infiltrate into the building. In this example, they are integrated within the windows. Intermittent extract fans are located within the wet rooms, the bathroom and the kitchen, and are only operated either by manual override or humidity. These then allow the moist and stale air to be extracted to the outside.
Extract rates are unchanged, but key points to be aware of are: if a wet room has no external wall, the fan should extract at 4 air changes per hour in order to meet the Purge Ventilation standards. It should be noted that for a larger wet room, this may exceed the minimum extract rate. For example, an internal bathroom of 15 metres squared would need a minimum intermittent rate of 60 cubic metres an hour, or 16.7 litres a second. Any automatic control, such as humidity control, should have a manual override to allow occupant to turn the extract ventilation on or off. And if no window is present, the fan should be provided with controls which continue to operate for at least 15 minutes after the room is vacated.
Background ventilators are now defined by single-story or multi-story. There is a 20% increase in area for habitable rooms and a 60% increase in area for kitchens. Fans and background ventilators should be at least 500 millimeters apart if installed in the same room, and if an external facade faces an area of sustained and loud noise, an attenuating background ventilator is needed.
If there is a habitable room that does not have any windows, you will need to ventilate through another room. In order to comply with this, there should be a permanent opening window, the 2 rooms of at least 1/20th of the combined floor area of the 2 rooms. Background ventilator of at least 10,000 millimeters squared. Purge ventilation should be present. There will also apply to continuous mechanical extract ventilation.
A system for purge ventilation is required in each habitable room to remove high concentrations of pollutants from occasional activities, for example, paint smells. Purge ventilation should be capable of extracting a minimum of 4 air changes per hour per room directly to outside. Purge ventilation should be delivered through either openings, such as windows or doors, or a mechanical extract system. Where purge ventilation is delivered through openings in a habitable room, the minimum opening areas which are specified in Table 1.4 should be achieved. There are minor changes when compared to the 2010 edition, where previously it distinguished between doors and windows. These have now merged into the table we now know as 1.4.
All internal doors should allow air to flow through the dwelling. The requirement is that there needs to be a free area equivalent to 10mm undercut to a 760mm wide door, which means either a 10mm undercut above a finished floor or a 20mm undercut above an unfinished floor. Although often overlooked on site, this requirement is just a minor rephrasing of the requirements compared to the previous regulation.
Here is an animation of decentralized mechanical extract ventilation. Similar to the intermittent extract fans, there are background ventilators which allow air to infiltrate into the building with the constant running fans located in the wet rooms. These fans operate constantly at a lower speed to ensure consistent removal of moist and stale air.
Here is an animation of a centralized mechanical extract ventilation. Again, we have background ventilators which allow air to infiltrate into the building with valves and ductwork located within the wet rooms, which allows the MEV to draw the moist and stale air through the ductwork and outside.
For MEV and DMEV systems, we have to look at a high boost rate and also a continuous rate. The minimum high extract is defined in litres per second for each of the wet rooms: kitchen 13, utility 8, bathroom 8, and sanitary 6.
As per our previous slide, the dwelling needs to meet the higher of the two results.
Background ventilators should not be installed in wet rooms, and when installed in each habitable room, should have a minimum size of 4,000 millimeters squared. There needs to be a minimum number of ventilators, which equals the number of bedrooms plus 2.
Unlike intermittent extract and continuous mechanical extract, background ventilators are not required. Stale and moist air is removed from the wet rooms via the ductwork, which is then extracted to the outside. Simultaneously, fresh air is drawn from the outside, passes through the heat exchanger where it recovers the energy and is then supplied to the habitable rooms.
For MVHR systems, we have to look at a high boost rate and also a continuous rate, just as we do for MEV and DMEV systems. The minimum high extract is defined in litres per second for each of the wet rooms: kitchen at 13, utility at 8, bathroom at 8, and sanitary at 6.
Here we repeat a slide for mechanical ventilation, where the continuous supply and extract rate has to be calculated in two ways, and the larger of the two volumes will be used.
The supply airflow rates need to equal the extract airflow rates. This will allow the system to be balanced, meaning the amount of stale air extracted from wet rooms is replaced with fresh, tempered air into habitable rooms. This needs to be achieved by proportionally distributing the airflow into each habitable room. Please note that background ventilators should not be installed with mechanical ventilation with heat recovery. Also, MVHR should be designed to avoid the moist air from the wet rooms recirculating to the habitable rooms.
Again, a repeat slide which also applies to mechanical extract with heat recovery.
As per section 2 of approved document part F, ventilation systems should be designed to minimize the intake of external air pollutants. Further information can be found via CIVSE's TM64 and TM40. Further expert advice should be sought during periods of high pollution concentration. It should be noted that mechanical ventilation with heat recovery systems are the only type of system that can minimize ingress of pollutants, as it provides supply air and has filtration options.
NOx filtration may need to be considered on city centre developments or where lower level dwellings are next to busy carriageways. Again, only applicable to systems that provide supply air rather than background ventilation.
Within approved document F, there are requirements to meet for installation and commissioning.
Mechanical ventilation systems must be commissioned by a competent person. There is a SAP benefit when the ventilation system has been installed by a competent person.
An installation comprises of many components, many of which are specified within Part F. Within Part F, it must be ensured that the system can be accessed to maintain the equipment and ensure that there are no obvious defects and that all packaging has been removed. Example of a good installation, on the left, where the unit can be accessible by removal of any obstructions, compared to a poor installation, on the right, where the unit is not accessible.
It is suggested that rigid ductwork should be used wherever possible, designing to minimise and pressure losses, to ensure efficiency and sealed to prevent any leakage. Examples of a good installation with each connections sealed properly compared to a poor installation where the flexible duct has been taped together using parcel tape.
Flexible ductwork should be kept to a minimum and ensured that the ductwork is taut and not sagging or has any tight bends to ensure system efficiency. As you can see from the images, ductwork should be straight and have long sweeping bends where possible, not tangled with multiple bends as per the images.
Airflow rates of all installations should be tested and noted down within the commissioning checklist. Correct equipment should be used to measure the airflow rates.
As per Part F, there is a compliance checklist that needs to be completed, which was previously part of the Domestic Ventilation and Commissioning Guide. This can be found within Appendix C and Part 1 is shown on the slide. Part 1 contains the particulars of the system, address and installer's details. Part 2A is an installation checklist. Part 2B is a visual inspection or pre-commissioning checklist. Part 3 is for recording airflow measurements from fans. All sections will need to be completed in order to demonstrate compliance.
As per approved document F, the Home User Guide is a non-technical overview for occupiers and should include some basic details on the operation and maintenance of the system. The operating and maintenance instructions provide further details as required.